Every day, you enter passwords, make online payments, and send personal messages. That highly sensitive information immediately leaves your device, plunging into the vast physical infrastructure of the public internet. It travels across a shared open space. So, what exactly stops anyone sitting in the middle of that network from simply intercepting and reading your data? The answer is encryption, the process of converting readable information into a format that only authorized parties can comprehend. Imagine writing a secret letter and locking it securely inside a physical steel box before shipping it across the globe. The postal couriers and middlemen can physically see, hold, and transport this box along every step of its journey. But without the key, they cannot access the interior. Digital communication works the same way. It relies on securing the contents of a package from the very people required to deliver it. We previously explored security tools like passwords, passkeys, one-time passcodes, and Face ID. Those authentication methods all share a specific limitation. They are designed solely to answer the question, "Who are you?" at the front door of a system. Encryption solves a completely different problem. It protects your information after you are verified, while your data is actually moving between locations. Verifying your identity at the start is useless if the system cannot protect the secrets you send during transit. Consider what happens when you type your standard password to log into an online banking account. Without encryption, this text travels linearly as plain text. Anyone intercepting the network signal can read it instantly. When encryption is enabled, the device scrambles that readable password into a chaotic string of random characters before it ever leaves your phone. To an eavesdropper sitting in the middle, the captured data appears only as meaningless, unreadable digital noise. This process is reversed through decryption. The intended bank server receives the noise and uses its unique key to instantly revert the characters back to the original password. Encryption acts as a temporary state of chaos, locking the information into an unreadable format solely for the duration of its dangerous journey. Because encryption is strictly a transit lock, it is not an impenetrable magic shield for all cybersecurity threats. If a device is stolen and left unlocked, if you use weak passwords, or if someone tricks you into sharing your credentials through social engineering, encryption cannot protect you. If the endpoint itself is compromised, the security of the transit journey becomes completely irrelevant to the attacker. Encryption is a single pillar of defense. It relies entirely on the user maintaining strict control of their physical devices and initial credentials. There is a common public misunderstanding that encryption somehow hides the very existence of our data. Returning to our locked box analogy, internet service providers and malicious middlemen can absolutely see that data packets are moving back and forth. Encryption doesn't stop people from seeing data. It stops them from understanding it. This raises an interesting paradox for platforms like WhatsApp. If your messages are end-to-end encrypted and WhatsApp technically cannot read them, how do they reliably deliver them? We will explore that in our next episode. If this video helped you understand the mechanics behind your digital life, please like and subscribe. We translate complex technology into clear, relatable concepts. Thanks for watching.